Good morning. Thank you for joining to this live session. My name is Ade Rodriguez, and today, as we already mentioned, we are going to be talking about our solutions for microwave sensors. And also, we are going to give some components, extra components or complementary solutions related to this technology. On today's webinar, my colleague Raul Dominguez and myself, Ade Rodriguez, are going to be presenting the information for you. On today's agenda, we are going to cover the basics for the motion sensors for this kind of technologies, motion, distance. We are going to talk about some popular technologies in the market. And of course, we will cover the microwave technology and give some examples for this of applications for this kind of products. In current designs, we might be familiar with some kind of motion or distance sensors, or even the most basic ones that help us just to cover or detect obstacles within the sensing radio or sensing distance of our sensors of our products. In most of the designs, or on the newest technologies, newest products, these kind of sensors are being implemented to trigger some actions inside our products, inside our designs. When we detect a motion, or we detect that an obstacle is close to our product, or even if we want to measure the distance of a person in order to activate maybe a light whenever we detect an object in less than certain distance, these kind of sensors are implemented or are being used in current designs. The most popular ones are, for example, if we want to detect motion, PIR sensors are the ones that are being commonly used. For distance, we might be familiar with camouflage technologies. And with the most simple ones are maybe infrared sensors that only help us to detect whenever an object gets close to our sensor or goes away from a sensor. That's the most basic ones. But as we can see, these sensors are being limited by the capabilities. They are only, in most of the cases, being able to detect only one action or two action tops. The reason for this webinar is to talk about the microwave sensors that, as we will see in the next slides, they help us to detect only more than one or two actions. Microwave sensors, as we will see, will help us to maybe implement the three of these technologies, or even more technologies, or even other kind of sensors, as we will see. Talking about PIR sensors, just as a feedback to understand what we are trying to promote today. PIR sensors, most of us are really familiar with these ones, and as we already know, they work by detecting the changes in temperature. So whenever a person gets in front of the sensor detects the change in temperature and triggers an alarm. The problem with this kind of sensors, or the main problem, is that if I stop moving, if the person stops moving, the sensor will stop detecting the person, the object, the object that detects that is generating the heat. So we might remember some cases when we need to wave our hands within the room in order to the sensor to trigger and turn on the light once again. That might be one of the problems with this kind of technologies. Of course, the distance. they are only they only work maybe at some limited distance, or the detection angles are really limited. I've seen maybe up to 180 degrees, but only up to that. If we would like to cover more radio, more angle, we will need to implement maybe more than one of these sensors. So there are some obstacles when we want to implement these technologies. And of course, as we already mentioned, they are only for motion. We cannot do more than that. If we would like to detect distance, for example, there are some other technologies in the market. Time of flight is the most common. They work by sending a laser LED signal, a photon, and when it detects an object, or this light goes in front of an object and returns to the sensor will detect the time it took to return. So with this information, it can be able to detect the distance of the person, of the object in front of it. Another issue, or talking about some problems with this technology, is maybe the distance. I've seen some cases when they are able to detect maybe up to 4 meters, 2 meters, no more, unless with some technologies. And of course, the detecting angle. They are not able to detect more than maybe 8 degrees, 10, 20 tops degrees. So it is really limited in the sensing area that we want to that it will work. If we want to implement a sensor that helps us to detect whenever a person approach from any a different side, instead of just in front of our product, the sensor won't detect until we get in front of the detecting angle. So they work, but if we want more than that, they might not be the right solution for us. And lastly, talking about the most basic ones of the sensor, of this kind of motion, object, obstacle detection sensors, we have the infrared ones. As we can see on the screen, they have an LED, an infrared LED, and an infrared sensor. So the LED sends the signals, and when an object is in front of this signal and returns to the sensor, the infrared sensor will detect and only will be able to send us an on or off action. It cannot only detect or send us or tell us where an object is in front or there is no object. So there are some constraints about this. Is the simple one, but if we want to implement more things in our products, it will be really limited. There are some new technologies. There have been some improvements on this kind of sensors. There are some others that can help us to detect even gesture, implementing some other arrays. But the distance for these gestures are really limited, maybe up to 10 centimeters, no more than that. And finally, we have already mentioned this before. We have the microwave sensors. The microwave sensors are basically a radar, like in the airports. They send a microwave signal. In talking about the radars in the airports, they send the signal in all directions, and when they detect or touch an object, in this case airplanes, they go back to the sensor, and the sensor detects based on the time it took to this signal to return. it measured the distance. What are the advantage or these kind of sensors? The distance, unlike if we want to detect or motion only, the distance for these ones are bigger than the other technologies that we already mentioned. The detection angle is bigger, not only 20, 50, 90 degrees. With this technology, we could be able to detect maybe up to 360 degrees of area, of angle. That is a comparison versus PIR sensors. If we are comparing this technology versus time of flight, once again, the detection angle is bigger than these ones. The distance, there are some examples when we can detect up to 15, 20 meters and still able to detect the motion, the distance, which is very, very important, or an advantage over these two other technologies, occupancy. If I stop moving, the sensor will still detecting myself. If I'm working within my office and only moving my fingers while I'm typing on the keyboard, these small movements with PIR sensor will not be detected. With this technology, we can there is an improve on the sensing capabilities. We can be able to detect the presence of a person and keep talking about offices, keep the light on while I am working. There are more advantage over with these sensors. Not only the distance, not only the motion, but maybe if I'm moving, getting closer to the sensor is going to be able to detect these motions and send me a trigger, send me an alarm to my processor, microcontroller, microprocessor. So there are many advantages over this technology over the other ones. Talking about these benefits or advantage versus other ones, we already mentioned some of them, but we can detect if the person is moving forward or is getting closer to our product. Talking about some fridges, we could be able to detect whenever a person approaches to the fridge, commercial fridges, and turn on the internal light, or it activates or triggers some alarm, some advertising. No matter when the person gets close, no matter if he's getting close from in front of the fridge or from any of the sides of it. Also, talking about PIR sensors, as we already know, as we already mentioned, they work by the changes in temperature. So, taking the example of an outdoor environment, outdoor product, LED lamp, for example, with a PIR sensor, during daylight, for example, if we or maybe a camera, a security camera. During daylight, if we want to detect whenever a person approaches to the camera, maybe the heat generated by the sun will stop or will trigger maybe false alarms, or maybe won't be able to detect to send an alarm because our temperature or the temperature of the person will be minimal to the one generated by the sun. Microwave sensors are not affected by these temperature changes because they work with different technology. This is one advantage. We also cover the areas that we can cover. We can cover bigger areas in distance, in viewing angles, in detection angles, and of course, since they work by using a microcontroller, external firmware, external programming, we could be able to program the sensor to minimize false alarms, to improve accuracy, or even detect more actions. Not only motion, not only occupancy or distance, but also, in some cases, in some application, even vital sign. With this kind of technologies, with these microwave technologies, we could be able to detect my heartbeat, my breath. So maybe in medical, in activity or health applications, there are more advantages, which I will cover later during this presentation. So these are just four or a couple of advantages I already mentioned, but as we keep moving or keep implementing this technology into our products, we will be able to take more advantage or more capabilities as we are moving forward or in trying to implement new firmwares into this application, into these ICs. Making a comparison versus PIR technologies, there's many of them. PIR sensors are already an established technology. Microwave sensors for these applications are really innovative. The programming, the things that we can do are bigger, can be more compared with this, saving space. And that is another thing that, another improvement on these technologies. If we want to implement this motion sensor into a camera, for example, we still need this plastic cover, which will maybe warn the people that there is a sensor and they can be detected. So it's not very discreet. With the radar sensor, also the space is smaller, and of course, it can be placed behind the plastic case. So the person that approaches to the camera, approaches to the sensor, ideally won't be able to detect that there is a sensor and that he can be detected by our product, by our system. Price is another thing we should be able to consider. Based on some technologies, most of the products for this kind of applications, based on some other products, for example, PIR sensors, our technology is cheaper. It has a better or can be very competitive. Even talking about maybe our solution, even compared with other products, other suppliers with same technology, there are some others that can be can have a bigger price compared with our solution. We already talked about environmental conditions, heat, but not only heat, maybe rain, water presence, humidity. This with the compare, for example, with light sensors, this light can be reflected to a different direction and the sensor won't be able to detect us or detect the object. Microwave sensors can work on these conditions, heat, humidity, rains, and of course, we mentioned this, the information that we can get from the sensor. It's not only on off or on off or off, sorry, but also range, motion, even velocity, speed, or the detection angle can be bigger than the one that we are getting from the other technologies. We already talked about the plastic cover, which with this technology is not required. And well, the ambient condition, the heat is not affected by that. So there may be many more advantages, not only versus PIR sensors, but also versus time of flight sensors. We can cover maybe this more with more details in another call, in a one-to-one call. But basically, this is how they work. This is how we can be better, or how you can improve your designs with this kind of technologies. We, myself, as a part of ION team, we can help you with, as you know, with some suppliers, with some technologies. My job here, or the purpose for me being here in front of the customers, is to help my team, to help the customers with some technology proposals, design proposals, and recommendations in some cases with some newest technology. In this case, we can, for this microwave sensor, we can help you with a supplier called Ridgewave, that has products. Ridgewave has products. It's mainly focused with RF components, which Raul lately during this presentation will cover. But they also have some sensors that can help you with your products. We have basically two different products. An IC that works into the 5.8 gigahertz range. This is a front end that is intended for motion detection and vital sign. As a front end, it requires an external microcontroller in order to have or embed the firmware. The other solution that we can help or provide is the 10 gigahertz sensor, an SoC with an embedded DSP, which allow us maybe to get off an external microcontroller, an external microprocessor, of course, depending on our application. And with this one, we have more advantage, not only motion, not only vital sign, but also we can detect occupancy, distance, and distance, not only the distance of one simple object. We could be able, because of the characteristics of the signal of this technology, we could be able to detect not only one person, but 2 or 3 persons sitting or standing at different distances. The sensor will help us to detect these 3 objects, these 3 persons, and with this information, we can maybe trigger some actions within our design. With the support of Ridgewave, and of course, with the support of ION, in this case, myself, Raul, my colleague Raul, and the account managers, we can help you on the design for this technology. We can help you on the implementation of this technology. We can help on providing schematics. We can help on providing PCB files, bill of materials for some design reference. And of course, we can help you with recommendations or with the design of the antenna. We might find, for example, some reference designs talking about the 5.8 gigahertz. We can find, or we can get some different design reference. And as we can see, with different antenna recommendations, depending on the product that you want to implement. A P antenna, a PIF antenna, we can be implemented for detecting distance up to 3 meters with a detection angle of up to 360 degrees. If we want to measure or detect more distance, 15, 20 meters, we can use a different antenna, a PCB antenna, with a detection angle lower, or a monopole with a bigger detection angle. It will depend on the application. We have some design example. We have some evaluation boards that can help you to test maybe most of the capabilities of these sensors, and they will work. They are working, but in an end product, we can help you to identify the correct design for your specific application. That is what we can do. What Ridgewave, with our support, can help you on your design. And with all these recommendations, the idea is also to give you, as we already mentioned, more ideas for the implementation of this kind of sensor. We mentioned motion, occupancy, which I want to I mentioned very often this occupancy because with other technologies, it is not possible to detect if I am not moving. These sensors can help us on this. We already talked about vital sign, not only for medical applications, but maybe for improving user experience, detecting if a person maybe inside the office is under a lot of pressure based on the vital signs, or for future designs, for future improvements, even being able to detect the level of the water maybe inside water tanks. So there are many advantages, many applications, and most of these, as we are going to mention in the next slides, can be applicable for maybe one of your products. Talking about these applications, the different applications or recommendation, we can review the lighting for indoor or for outdoor application. With this sensor, we can not only detect the motion, but also maybe the distance. How can we use distance for these products? Indoor applications. We want to turn on the light whenever a person approaches maybe and specify a certain distance from the object. Not only to detect me when I'm getting close, maybe, or if I am 4 meters away from the living room. I just want to maybe turn on the light, or when at full percent, 100% of the power, when I am 1 meter, or when I am inside the dining room. Or maybe if I am in the next room, I just want the dining room to turn on the light at 20%. So this can be one of the advantages of using this technology, not only for motion, but for distance or occupancy. Indoor applications, for indoor application, we can detect whenever a person is, I mentioned this before, this example before, but if I am working and I am not moving, the sensor will be able to detect myself and keep the light on while I am working. On outdoor applications, we've been giving this sensor for these applications. We've been giving this recommendation of technology for outdoor lighting. Maybe we can create a mesh network, a wireless network or wired network with all the street outdoor lights, and we can use the sensor to detect whenever a person of a car is approaching or is within the area. So we can maybe turn on the lights at full output power, and when we detect the motion of a person. And when there is no motion, maybe put them all at 20% or at less output power. Of course, this can help us on extending the life of the LED lamps. And talking about the mesh network, we can send notification. And we already mentioned this, send the alarm to trigger or trigger all the lights to be on. Talking about HVAC, air control or air condition control, is kind of the same example as we already give for the indoor. We can detect, for example, conference rooms. If there is 1 or 2 people inside the room, inside the conference room, inside my office, and still keep the air condition on. If there is no person, if there is no one within inside the conference room, we can turn off the air condition. Talking about this air condition or air control, maybe we can give the example of Airbnb. We don't want to go as the owners of the house or the place that we are providing for our guests, we don't want to, we want everything to be controlled remotely. We don't want or to get into the house and turn on the air condition, or we just want it to be work without any external control, with autonomy. Or maybe when there are guests inside the house, maybe turn on the light only when they are in, moving or not moving, sleeping or doing some activities. With these sensors, we can control this. And with a wired connection, we can get, talking about synergies of products, we can have the alarms or the information in our telephone with all this information, right? So not only detecting the occupancy, but detecting how many people are in the room. With some future designs or improves, could be able to detect maybe how the position of the people inside the room, something like indoor tracking. So there are many advantages over this technology. Talking about smart home, which is still related to indoor lighting, to HVAC systems, we can implement these sensors for triggering, for replacing mechanical switches, or for those sensors with small lights that turn on when they detect motion. We can change these PIR sensors to radar or microwave sensors to detect, to improve the detection angle. We are seeing, or we can see also these products or radar microwave sensors in smart devices, like these cleaners or robots that help us to keep clean the floor of the room. They are, because with the 360 degrees sensing capabilities of these microwave sensors, these robots can detect whenever an object gets close, if there is a chair or a door close to the robot. This is and with all the support of the microwave sensors. For e-health, we already mentioned vital sign, being able to detect the breath, my heart rate, and with this information, monitor, keep doing some track monitor of the sleeping of the person, or in fitness applications, we could be able maybe to implement this sensor in front of in the dashboard or in the front panel of the device, and detect how the guy is, how is the working, or how exhausted is the person that is doing the workout. And another kind of application, detect the object, detect the level of certain liquids, water in this case. For automotive, this kind of sensors can be implemented for aftermarket products, but still being able to detect or send triggers for detecting how close or how far are the other cars from our car. Or in parking stations, parking slots, normal sensors are, the detection angle is really narrow. With this one, if the people, well, if there is a case where the car is didn't park as it should, with this sensor we could be able to detect if there is a car in a bigger area. We already talked about the smart cleaners or these kind of robots. And I think we didn't mention this, but we also can support another application is the cameras. Replace PIR sensor with microwave technology to detect or to trigger alarms whenever a person approaches or gets close to the system, to the camera. So the advantages over this technology is, as we could be able to watch over these slides, could be many, and we could find many other advantages. And depending on your product, we could be able to help you with some recommendations. Of course, since they work with RF technology, we already mentioned we can identify different antenna requirements for our product. There will be the need, maybe in some cases, to implement some other RF products. So for this part of the presentation, my colleague Raul Dominguez is going to talk about these products or these recommendations.
Hi, everyone. My name is Raul Dominguez. I'm an FAE for ION. I'm specialized in RF and IoT devices. So let's start. Next slide, please. I'm going to talk about the RF discrete design, which we have some devices and components that can help you. Generally, you have an RF radio. It doesn't matter if it's Bluetooth, cellular, Wi-Fi, LoRa, Sigfox, etc. If you're doing a discrete design, you need sometimes a power amplifier, or you need a low noise amplifier. If you use any of these, you will need a switch, an RF switch for the antenna. And then at the antenna side, you will need, of course, the antenna that could be outdoor, internal, embedded, or a custom. And you will need the matching components, inductors and capacitors. In RichWave, we have these devices, the front-end modules and the power amplifiers, the RF switches. And as you can see, big names are our customers: Samsung, Sony, LG, Nokia, Asus, and some other Chinese that are massive in the world, mass production. So you can tell that RichWave is both quality in the technology and also a good price. We have several product families. As you can see here, we have, for example, for Wi-Fi, the front-end modules that has the power amplifier, the low noise amplifier, and the RF switch. And it depends on which chipset you are using. We have components that match better with Qualcomm, some with MediaTek, with Broadcom. So at the end, you can tell us, hey, I'm designing with this chipset, and then we will give you the best option. Here is a closer look on what a Wi-Fi 6 looks like. In the left side, you can see that we have the 5 gigahertz and also the 2.4 gigahertz. Also, this one has an embedded Bluetooth. So we can offer you either of these in a separate, for example, power amplifier, low noise amplifier, or the switch. We can offer you a reception RX FEM that only has the switch and the low noise amplifier, or we can offer you the full FEM that has all the 3 components. This for 5 gigahertz and also for 2.4. After that, you can use a duplexer and you can use a single antenna for these technologies. In the power amplifier, we have mostly for Wi-Fi. We have also, and can be used for Bluetooth, but normally they don't use this because now Bluetooth is going towards to having the low energy. So it's not very used to have to amplify that. But we have for 5 gigahertz for 2.4 gigahertz, and you can see the output, power output. We can go up to 23 dBms on 5 and 26 dBms on 2.4. For LNAs, we have for several technologies. We have for Wi-Fi, we have for LTE. This is normally used when you have several radios on a device and you will need a LTE LNA. We have for GPS, we have for LoRa, NB-IoT, and others for gigahertz. So we have a broad range of LNAs that we can help you with. We have one for GNSS that is going to be out in the market by September, kind of, in mass production. And we have the RF switches. We have several configurations, single pole dual throw, dual pole dual throw, and several combinations. And we have what are the frequencies that we're working with. So here you can see the input, what is the loss, the insertion loss, and we have low insertion loss, and we have switches that can go up to 7 gigahertz. So those can be used in Wi-Fi 6E. We not only have for Wi-Fi, that is the more normal usage, we have for LTE, NB-IoT, LoRa, and other sub-gigahertz protocols. For the front-end modules that are the ones that has everything on them, I already told you that we have for 5 gigahertz and 2.4 gigahertz. We have for Wi-Fi 6, that is the AX and below. And we have the RX only. If you can see, we don't have a power amplifier here, or we can have the one that already has a power amplifier and low noise amplifier. We also have some FEMs that are suited for and qualified for automotive. You may need more components, more discretes, and we have another line brand that can help you. This is Pulse. With Pulse, we have several antennas. I will show you a couple. We have the inductors for the matching circuits. We have couplers, duplexers. If you recall the last slide of the Wi-Fi 6, they was using a coupler, so we have those. We have filters, low band and bandpass filters, and we have buttons. So if you need to help with the discrete design, we can help you with several components. And talking about antennas, there are several types. We have the embedded antennas. Those are the ones that are soldered on the PCB. As you can see, we have chips, we have some SMT helicals, normal helicals, composite that are kind of PCB, the patch antennas that are very used in GNSS. And we have broad bands that we can cover. We have internal antennas. Those are the ones that are enclosed in the casing, but are not accessible from the outside. Normally, these are stickers, PCB flexible. We have some rigid PCBs also. And the length of the cable can vary as you want. So, for example, this one, in here we have a MIMO LTE. So it has the normal LTE antenna, the diversity antenna, and we have the GNSS antenna. So you have 3 cables in one single sticker. We have for the same for several protocols, for several frequencies. We have also the outdoor and the external antennas. The external are the ones that are normally seen on the routers that you can move. For example, these ones that are, you can change the position, the angle, or fixed. But we also have outdoor. We have the ones that are used in the gateways. For example, Cisco uses some of our antennas. Sigfox uses our antennas for their gateways. Yagis that are directional for normal radios, and these other types that are also IP65 or 66. We have vehicular antennas. In here, you can have one or several antennas inside one of these. These are tamper-proof, so those are assembled with a nut into the case, and you can select what you need. Finally, we have the custom antennas. In here, we see that all the devices are becoming smaller. So it's more difficult to have a good antenna in there. So we can have a custom antenna for you. We have two technologies. One is Fluidant. With Fluidant, you will be printing the antenna on the plastic part that you already have that in your assembly. Of course, Pulse does the design, the testing, and the printing. And well, this technology is recommended up to 50K per year because of the pricing, although we have the capability to do 1 million per year. But starting from 50K, LDS become cheaper. LDS is laser direct structuring, where you mold with a special plastic the part. Then with a laser, you pass the laser on the plastic where the antenna will be printed, coated, and it changes the structure. So then you do as a normal PCB, the coating and the plating, and you have the metal on the plastic, and it's at the end can be a bird chip antenna, although it has the pricing of the tooling, right? Like any plastic, and Pulse does the injection. So that's for antennas. I wanted to talk to you about also another brand that we have, that is Chalink. Chalink is a company that creates and manufactures wireless SoC. It's more focused on Bluetooth. This company, Chalink, is part of the SIG Association. They were there when the SIG mesh was created. Indeed, they provided a lot of technology to create the SIG mesh. Now we have up to Bluetooth 5.2. With 5.1, you can do also interpositioning, and we're releasing the Bluetooth audio. So if you have any need to have audio over Bluetooth, we will have a SoC in the next months ready to do it with in an internal DSP. Another protocol that can be used with these SoCs are Zigbee, a proprietary HomeKit, Thread. There's a lot of possibilities. It's very powerful. They have a lot of stuff in there. One of the things that is, that creates the value of this is the silicon size. It's one of the smallest, so that's why they achieve a very low price and a very powerful structure. So this is one of the first SoCs that have the HomeKit available.